My name is Erhardt. I'm a dev on the dotnet team. And so I'm here today to talk a little bit about Aspire components. And so probably heard this already, but exactly what are Aspire components? Well, they're just NuGet packages that connect client libraries, like existing client libraries that people use in their cloud apps, to the .NET Aspire stack. And so you might kind of first question was, why would I even need another library here? Why can't I just use the underlying client libraries themselves? And so in order to answer that question and kind of describe what Aspire components do, I've set up an application that what the world would look like if we didn't have Aspire components. And so I have a .NET Aspire app here, and it's kind of the classic weather application that we've used in a lot of our talks and documents and whatever. So I have a weather page, and it just does our random weather forecast for the next 5 days. And I want to be able to cache the output of this page for 5 seconds. And so that way for 5 seconds, I'll get the same weather forecast, but then when 5 seconds is up, I'll get a new one. So this app's already hooked up to use output caching. So I already have the output cache on my page, and I have add output cache in my app. And the issue is that as my app scales horizontally, doing just the normal output caching, each replica of my app would have its own output cache inside of it. And that's not really what I want. Instead, I want to have like a centralized caching place to put these cache entries. And so in order to do that, I'm going to use Redis caching. And so in my Aspire app host, not only do I have my weather app, but I also have added this Redis server, and I gave a connection, this with reference from my weather app to the Redis server. So now I have a Redis server that my app can talk to, and I need to hook it up. And so the way I can hook it up is I go online and I read the documentation, and it says, hey, if you want to use output caching with Redis, all you have to do is install this NuGet package and then call this one line, add Stack Exchange Redis output cache, and you'll be hooked up. So I'll go and do that in my app. If I go back to my app, I'll add that NuGet package reference to ASP.NET output caching Stack Exchange Redis. And then in my program.cs file, I don't want to just call add output cache. Instead, I want to call Stack Exchange Redis output cache. And this is basically the one line that the documentation showed me, is that I can get that connection string and pass it into this options.configuration. And the connection string name is the same name, right? This cache is the same name that I used in my app host. That's how the two things talk to each other. So this is fine, and now my app is using Redis as its output cache. But when I actually deploy my app, the Redis server that it's talking to is shared by many different applications. It's not just my app that's hitting it. Many different applications hitting that same Redis server. And so what kind of the service team tells me is, hey, you need to set the client name on your connection, so that way the server can tell which apps are using more or less of the resources on the server. And so learning a little bit more about Stack Exchange Redis, I find out that there's this configuration options object that allows me to change how I my connection, and it allows me to set different settings onto it. And if I look at some of the settings on here, you can see like allow admin, backlog policy, but there's this client name setting. So great. But I don't really want to hard code in this client name into my code, because my app might be deployed in many different deployments, and the people who are running my app might actually want to change the client name depending on where the app's deployed. So instead of just hard coding this client name into my app, I'm going to want to be able to configure using ASP.NET's configuration system, how to change these options. And so that's pretty easy. So I can come in, write one more line of code that says, get the Stack Exchange Redis configuration section and bind it to this configuration options. So that way I can set all those settings in configuration. And now instead of just passing in the straight connection string, excuse me, I can set the configuration options on the object. But next, I want to be able to test, I need to configure it first. Sorry, so I go to app settings, and now I can come in here and write my configuration, but I don't really know exactly the format or the string. I hope I'm pasting this right, but Stack Exchange Redis, set the client name property to weather app. So I want to be able to test that this actually worked. And one of the things on the configuration options I can set is this logger factory. What the logger factory allows me to do is use the logger that my app uses. I can pass that into the Stack Exchange Redis client, and its connection will use that same logger. So Copilot's being very helpful here. It's trying to tell me, use builder.services, get required service, iLogger factory. And the end is right, but this builder.services doesn't exist because in ASP.NET apps, you actually have to build the app before you can get the DI container, the service provider. And so now I'm kind of stuck a little bit. How do I get this logger factory so I can pass it into my configuration options? Maybe I find online somewhere, but this O options that's getting set here is a Redis output cache options, and it's just an I options in ASP.NET. And so I can configure it just like I can configure any other I options, right? I can just say services add options, that options, and configure it. And now I actually get a service provider passed into me that I can use. So I can pull this code out of here, all of this code out. And now instead of builder.services that doesn't really exist, I can use the service provider to get my iLogger factory. And then this code just becomes basically blank. The configuring this. This line adds the necessary services, and then here's me configuring the Redis output cache options. So now I can configure my client library. I have logging. We'll try running the application. And you'll be able to see it working a little bit. So we have the Aspire dashboard here. If I hit my app and I go to the weather page, you see generated one at 2:38. If I refresh it a couple times, after 6 seconds, I got a new weather forecast. If I come and look at my logs for my weather app, you'll be able to see that Stack Exchange Redis actually is pumping logs out. And if I search for a client name, you'll see setting the client name to weather app. So perfect. Logging's hooked up. Configuration's hooked up. That's great. However, I shouldn't have closed that window. However, given the cloud world, right? Sometimes things fail. Sometimes that Redis server just goes down. And so to simulate that, I'll come into Docker and kill this container. And now my app kind of struggles, right? Because it's trying to make that connection to that cache. That cache is down. And you see it took a little while. It sits there thinking when I try to refresh because it keeps trying to hit that cache. But my health, if my health system tries to check to see, hey, is this app still healthy? It hits the health endpoint. Still says healthy. It's but obviously it's not healthy because if I actually try to hit it, it's hurting, right? My app's not working very well. So again, go back to search online and I find that, there's a health check library that you can add called ASP.NET Core Health Checks Redis. So I grabbed that NuGet package, add it to my app. And there's one simple line I can add. I say builder.services, add health checks, and now I want to add a Redis health check. And the options I'm given here are I can get the connection object itself, can just pass that in. I could give it a connection string, or there's a couple factory overloads of giving an iService provider to create me a connection. Well, I don't want to use a connection string because if I gave it a connection string, it would make its own connection to the Redis server. And then I would have two connections, right? My output cache would have one connection and my health check would have another connection. And that's not really what I want. And I don't have the actual connection object, right? I was just passing the configuration options here and the output caching is adding it. So what I really want to be able to do is extract the connection object out into its own DI service, into one singleton service that both the output cache will use and the health check will use. So that way, if that one connection goes bad, my health check starts reporting, it's unhealthy. So to do that, I will come up and I'll say, I need to add that iConnection multiplexer as a singleton object to my DI service. Now I can lift this code up, and Copilot helps me saying connection multiplexer connect. So now the connection multiplexer is in as a DI service, and I can come back to configure my Redis output cache options. I can say that the connection multiplexer factory is a factory and returns a task of connection multiplexer factory. And then similarly for my Redis health book check, I can say its factory same thing. So now the same connection is being used both in my output cache and my health check. When I run my app one more time, and then simulate the server going down, the app's still busted because it can't make a connection. But at least when my health endpoints check, when somebody hits my health and says, is this app healthy? Now it's sitting there waiting for a little while, thinking, trying to make that connection, and said, nope, not healthy anymore. It's unhealthy. Perfect. That's exactly what I wanted my app to do. And then lastly, it would be great. The service team tells me it would be great that if we could have some sort of way of knowing when the cache got hit or when the cache got missed. And so I need some sort of telemetry, right? Go back to searching, and I find that there's an open telemetry instrumentation package called Stack Exchange Redis. Sounds like exactly what I need. And then now I can add my, on top of after my health check, I can add open telemetry and say add Redis instrumentation. And looking at the docs for this, I don't know why they're not popping up. Anyway, this one, it says, note that the connection multiplexer is resolved using the application service provider, which is exactly what I want. So all three of these things are using the exact same connection. And so finally, I think my app is now fully done. I have be able to configure Stack Exchange options, use all configuration. I have telemetry hooked up. I have health checks hooked up. I have logging hooked up. And so if I go hit my weather endpoint and hit a couple times of the cache, I can come look in my traces. And the first time this weather endpoint got hit, you'll see that it tried getting the cache. Well, that wasn't the first one. I was too far down. The very first one, when I hit, you'll see it makes the Redis connection client. It tries getting the thing out of the cache. It doesn't find it, so it does some processing and then puts the end result in the cache. And the one right after it actually came from the cache. You'll see that it just got it out of the cache, used it, set it back. But wouldn't there be, like, this is where we've looked at this and we thought, for every different kind of thing that I want to write, whether it be a Redis connection or a database connection or a queuing connection like RabbitMQ, if I had to figure out how to do this for every single one, like, I would save me a lot of time if somebody just made a pattern for doing this. And so this is where Aspire components come in. So in my application, if I right click and say add .NET Aspire package, we get a view of the NuGet packages, but they're filtered down to be Aspire components. And you can see all the ones that we have already available. There's 3 flavors of Redis today. There's just a plain generic Redis client. And then there's a Redis output caching and a distributed caching. We want the output caching one. And so we install that into our app. And now we can remove those 3 NuGet packages referenced, right? We don't need these 3 anymore. And instead, we just have the Aspire Redis output caching. And instead of this 20-some lines of code, I can now remove and just say builder.add Redis output cache. Then the thing it needs is a connection name, which is the same name, again, as that connection that's passed through as before. So instead of getting out of the connection strings, I get it from it. And so now my app should work exactly the same. I don't have to manually write that code anymore. The Aspire component does it for me. I go hit my app, refresh. It's working the same. It's being cached correctly. I go view the logs. I get logging hooked up. And then one more check to see, did that configuration still work? Nope. Unfortunately, it didn't. Like, the client name now fell back to my machine name plus the Redis version. So it's no longer weather app. And so why did that happen? Well, if I look, reading the documentation about the Aspire component, that I just made this section up when I wrote it manually. There's just a Stack Exchange Redis, and that's where all the configuration would be. So the Aspire component made a different section, is reading it from a different section. And now if I look, I actually am getting more IntelliSense about this app settings JSON. I can see there's an Aspire section with Stack Exchange, Redis, and then that configuration options object that we were talking about. And if I look on that, I can see here all the properties that configuration options takes, that I can configure. And so client name is one of them. And so now I can just set client name to that. And now the configuration options is configured correctly. And I can configure other things here and figure out what are the other things that can be configured. So that's great. If I happen to not want all those information messages, right? If I only want like warnings and errors coming out of Stack Exchange, ASP.NET has this logging log level section where I can configure the different log levels for the different categories. Well, previously you would just have to guess or somehow know what log categories are available. But also with Aspire components, we bring in this metadata to know that there's a Stack Exchange Redis category, and you can set it to warning. So not only can I configure my configuration options, but also my logging level and get IntelliSense for those things. And then lastly, this one line of code is great, but sometimes you don't want all the things. You want to be able to say, hey, I don't really want the health check, or I don't really want tracing for some reason. Maybe it's getting in the way, or it's causing problems. And so there's 2 ways, there's 2 callbacks that are passed in every Aspire components. There's there's a way you can configure the settings object. And so the settings object is the way the Aspire component works, right? Like it'll add health checks, it'll add tracing, and you can disable those things. And separately, there's an options callback. And this options callback allows you to configure through code that configuration options, right? So it's two separate ways of being configured. The settings object is the Aspire component functionality, like what things should be opted into DI, where the options callback is the configuring of the client library itself. And so there's a few things on for Redis where you can't configure this through a configuration like a JSON file. So in this example, this reconnect retry policy, it's an interface, like you have to write code to be able to configure these things. And so that's why there's these two separate callbacks, one for the Aspire functionality and one for the client library functionality. You'll see that pattern in almost all Aspire components. Moving on, I have a separate app. I have a separate app that looks almost exactly the same, but instead of just giving random weather forecasts, I wanted to talk a little bit about our database components. And so this app reads the weather from a database. And right now it's configured to use, it's using the plain NPG SQL, like the raw data connection APIs, which is just the Aspire NPG SQL component. Now I want to switch it over to use the EF flavor. Most, if not all, of our database components have kind of two flavors of packages. One is just the straight, ADO.NET DB connection level component, and then another flavor of Entity Framework. And so in my program CS file, instead of calling add NPG SQL data source, passing in the weather connection, instead I'll call add NPG SQL DB context and give it my Entity Framework context. And then since it's the same Postgres database that's being talked to, this weather connection is the exact same, right? It's pointing to the same database. And then in my weather page, instead of injecting an NPG SQL connection, I'll inject that weather DB context. And then instead of hard coding my select statement into my page, I can just use Entity Framework to query the database. So that's kind of a description, a little bit of our database components, why you'd want to use either one. One piece of feedback we received a lot about with the Entity Framework version is that currently, or by default, the add DB context overload adds the DB context as a pool DB context, which isn't always what you want it to be. Sometimes you want to use a DB context factory, for example, if you're using like Blazor server. And so instead of us providing all the different ways you could try to configure DB contexts in the Aspire component, what we decided to do is to allow you to just use the normal Entity Framework APIs to add the connection, to add the DB context. So you get all the different ways if you need to change what lifetime of the DB context DI service. You can configure DI with Entity Framework the way you normally do with any other Entity Framework app. And then we added this enrich DB context API. So what enrich does is it does everything that the add DB context does, but it doesn't put it into DI. It allows you to have full control of how the DB context gets put in DI. And then the enrich method comes along and puts all the other Aspire functionality into that connection. And then the last thing to show here is that, you sometimes when you have you have more than one connection to something, right? Like, so in the case of Redis, you might need to have multiple Redis servers, like 2 different connections, or even 2 connections to the same server. For example, like maybe you have really big payloads of output of caching that you need to put on one connection, and then a bunch of little small ones that you don't want to block behind these big ones. You want to put them separate. And so the other pivot you can do with Aspire components is, instead of just saying add Redis client or add Redis output cache, is that there's these keyed overloads. You can add a keyed Redis client. I don't know why. Where this key is this name that you pass in is both the name of the connection that reads from the connection strings, but also the key that you get out of DI. So when you have app.services.getKeyed service, the key that you pass into getKeyed service, the key that you pass in to get the service out is the same name as what you passed up to here. So in cases where you need multiple things, say database connection, Redis, whatever, you can do it through DI keys. Okay, so I think that kind of explains why we built Aspire components and what they do. Kind of to recap some of these fundamentals. Configuration allows you to configure your client library pretty quickly and consistently. It injects things into dependency injection to be used inside your app. It enables telemetry out of the box. It enables health checks. If the library needs some sort of resilience setting that doesn't come by default, it tries to do that. And then I didn't show fully documentation, but the configuration schema is a form of documentation that shows what things can be set. And then every Aspire component comes with README, learn.microsoft.com documents. And so real quick, going through some versioning of how this works. Aspire components version with .NET Aspire, and .NET Aspire versions with .NET, or it gets its major version from .NET. And so like we just shipped 8.1 this morning. So the 8.1 components all target Net 8.0. When .NET 9 comes along, it's not going to be an LTS. And so we thought it would be unfortunate to force people to move to .NET 9 just to take advantage of .NET Aspire 9. And so instead, Aspire components will be able to be used both in Net 8 and Net 9. So even though you're using the 9.0 version, you can still use it on an LTS.NET. And then when 10 comes along, it'll be LTS. It'll get used. It'll be Aspire 10. We'll target .NET 10. And then in the second line is pretty important. Depending on the latest underlying client library versions, that can kind of come with a problem. So we service regularly, and we want to always be on the latest client library versions. But sometimes those client libraries have breaking changes. And we have one concrete example of one happening right now. The RabbitMQ client library, V6 is what the Aspire component uses. V7's in preview, and it has some breaking changes in it such that the Aspire component can't even load anymore. And so in Aspire 8, we're going to do 2 things. We put the upper limit on the dependency so that the V6 will always get used, and we'll fork a new package with a suffix .v7, so people can choose, do they want the V6 version or the V7 version? And people who are on V6 don't get broken by a V7 version coming out. And then when Aspire, the new version comes out, the major version of 9 comes out, we kind of flip those 2 things around. And so if the older V6 library is still in support, that one will get the .v6 suffix on it. And then the V7 one becomes the main package moving forward. So this allows us to kind of straddle these versioning requirements of not breaking people when a breaking change comes out in the underlying client library, but on a major version, when you're updating to Aspire, the new Aspire versions, now you have time to take advantage of this new breaking changes. Or you can stick on the old one by using the dash V6. So versioning is a little bit hard here because there's kind of two versions we have to work with. There's the Aspire version, the Aspire and .NET version, and then there's the underlying client library version. And sometimes if you have to kind of pick which one you want to follow along. So I think that wraps up all that I have to talk about. I think that's the end of my.
Hey, Eric, how you feel on this presentation, my man? I have a question.
Sure.
I don't know, production, and if I don't have time, ping me. But can we get this question from Zui? I don't know how to speak your nickname. I apologize. So how can I expose health checks for my own components so they are reflected on the dashboard? For example, my API has Kubernetes probes set up, ready, live, and I don't see those on my dashboard.
So specifically, the Aspire dashboard doesn't yet show health checks. It doesn't show those health endpoints, but that is a feature that we are looking at adding in a later release of adding health checks into the Aspire dashboard. In this one.
Gotcha. So production pinged me because I have a question for Eric as well. Eric, I want to know one thing. You showed me a lot of great components, but you said like only Redis has already free components. So what should I take a look? What do you think we should look onto choosing the best component for my application? Because if they need to have some differences between them, right?
Between those three Redis
exactly
components. So they're all like the plain Redis one is just if you want to use the Redis API directly and write your own code that's talking to Redis. The other two are built on top of that base one, and it depends on how you want to use it. So output caching is what I showed today, where ASP.NET has the feature of caching the output of a page. There's also a distributed caching where it's a higher level API where you can just get an iDistributed cache and you don't know the backend it's talking to, and you can inject Redis or maybe a SQL Server or some other caching technology. And so that's how you would decide if you want to talk straight to Redis using the APIs itself, if you want ASP.NET to talk to it, or if you want to talk to the higher level distributed caching. And yeah, I didn't show all the other components, but yeah, we have queuing components and Azure components, etc. So I just kind of dug into a deep one to show all the different ways, all the different design approaches of components.
Gotcha. Do you have any last messages for our amazing viewers here at Aspire Devs Day?
No, just try it out. Give us feedback. We're on GitHub, open issues. Tell us what's good, what's bad. Discussions as well. So,
gotcha. You listen to Eric. We want that feedback. Give us feedback. We want our feedback. Thank you, Eric, so much for this incredible presentation on collections.